The last mode of operation I'm going to talk about is called Cipher feedback mode, also known as CFB. There are many different modes of operation. We won't talk about them all, but the ones that I've talked about will give you a good sense of the way modes of operation work. This one's a bit different from the others that we've seen so far. It does use some encryption function as a black box, like the others. We'll call the input to that encryption the X values. So X0, X1, X2, ... are the inputs to successive encryptions. The first one will be an initialization vector, similarly to how we've used that in other modes of operation. And that will be the input to encrypt. There's also a key. The output of encrypt is some encrypted block. We'll use n as the encryption size. So for AES, we'll assume n is 128 bits, whatever the block size is. So the size of the input block and the size of the output from encrypt is 128 bits. This cipher has an additional parameter, which we'll call S. And S is how we're going to divide the output. We're going to take the first S bits of the output, and those will be XORed with the message, with that message block, producing the output ciphertext. This looks very similar to CFB, except for we haven't used the entire output here. The other thing that we're going to do is we're going to use the ciphertext to update the X value. So we're going to take these S bits, we're going to put them into the next X value, and we're going to move the old value S bits to the left. So that means we're going to be taking the n minus S bits that are the right part of the previous value of X0, and we're going to be moving those into here. Everything else proceeds the same way. We encrypt the X value, we get our output block, we take the leftmost S bits of it, we XOR those with a message, we get our ciphertext block. And this keeps going. So we can describe that process. First, we'll describe what happens with X values. So value Xi is the result of taking the previous value of Xi. So that's value Xi minus 1, so the left value of Xi. Taking from position n minus S to the end. I'm going to use Pythonic notation for this. We're taking from position S to the end of the previous value of X, and we're concatenating that with the value of the previous ciphertext. So this is defined as a recurrence. We need to define the initial value, and that was given by the IV, the initialization vector. So that's how we update the X values, how we compute the ciphertext values. We compute the ciphertext values by taking the outputs here. That's the result of encrypting using key K, the X value for that position. And we're going to take just positions up to S, and then we're going to XOR that with the message. So this is how we compute the ciphertext blocks in the cipher feedback mode. The important thing that you should notice here is there's this additional parameter S, and what S means is the size of the message block. And the value of S should be less than the value of N. That's the normal block size of the cipher. Otherwise, we wouldn't have any input left. It would end up being a different mode.